Now let's get started with the first technology panel discussion of this conference. I am Satish Tokala, working as Aero Defense and Space Industry Manager at MathWorks. I am honored to invite Dr. Ranjan Ganguly to lead and moderate the panel. Dr. Ranjan Ganguly is currently a professor of aerospace engineering at the Indian Institute of Science, Bangalore. He received PhD in aerospace engineering from the University of Maryland at College Park. He has published over 200 journal papers and 7 books. He is a fellow of the ASME, associate fellow of AIAA, and fellow of the Indian National Academy of Engineering. I am happy to invite Mr. Nitesh, Senior Vice President and Global Head of Engineering Services at Infosys. He is passionate about bridging the physical digital divide, advocating AI, machine learning, and process automation to amplify business value. He has worked with numerous clients, helping them understand ways to leverage Industry 4.0 and IoT technologies, and currently sits on the World Economic Forum Global Future Council for Advanced Manufacturing and Production. I'm glad to invite Dr. Samir M. Prabhu, Worldwide Industry Marketing Director at MathWorks. He has over 25 years of experience in fostering the adoption of MathWorks products for technical computing and model-based design across vertical industries. He received his PhD in mechanical engineering from Duke University, specializing in robotic controls and artificial intelligence. His efforts have been documented through United States patents and global publications. I'm glad to invite Mr. Uma Maheshwar, Chief Consulting Engineer for 700 plus member GE Aviation India team, developing next-gen aviation technologies and software and supporting fleet. Uma has over 28 years of experience in setting up and leading large engineering organizations. He has presented papers and thoughts in 125 plus national and international conferences. Uma is a member of SAE Aerospace Forum, NAFEMS Board, NACCOM, Engineering R&D Council, and academic industry bodies. I'm happy to invite Group Captain Shivakumar Ramachandran, who is an Indian Air Force veteran and currently Engineering Director and Site Head of Honeywell Technology Solutions, Hyderabad. He is a qualified experimental flight test engineer and graduated from the Indian Air Force Test Pilot School. His career in the field of military and civil aviation spans close to 35 years across requirement definition, avionics systems development, aircraft upgrades and acquisition, assessment of aircraft performance and flying qualities, maintenance, and systems integration. So today we have the perfect combination of panel members with expertise mix of OEM, solution, and technology providers and engineering services. Let's hear from them. Now I request Dr. Ranjan to start and moderate the discussion.
So I'd like to welcome all the guests today. Basically, we are going to talk about the technology landscape following COVID. Now, as you all know, COVID has been quite a devastating pandemic which has swept the world. And we had till now about 45 million cases and 1 million deaths. And as far as the pandemic is now, it's on to its second wave, and maybe there are going to be more waves in the future. Now, one of the things that COVID has done is it's changed a lot about airlines and how they are going to work in the future. So that impacts the all kind of aspects of this field. So I just give a few of my thoughts on that. For example, right now we have a hub and spokes model for airlines, and maybe there is a more of a need to go for point-to-point flight models. So that's something which is going to come up, and that is likely to favor aircrafts which have longer range, which may have lower seating capacity. So again, there may be some change in the platform configurations which are more useful for the market. One more feature we see which has come up is that of like travel bubbles, where again you are creating point-to-point travel situations. And you may want to actually skip the hub countries because you don't want to get COVID tests in those countries. Now, what are some of the technology implications of this pandemic? I think one is it's brought in focus health. Health was a topic which was not on top of the technology people in this part of the sciences. So I think that is something which is becoming important. Till now, we have kind of security checks, security monitoring, but in future you are also going to require health monitoring of people. So probably people will have to go through a extra security check for that. As far as airplanes are concerned, the health aspect is going to become much more important. So there is going to be need for some kind of treatment of different viruses, how to clean hands without maybe using a lot of water, and how to serve food without problems. And on top of that, this is going to pressurize the various companies to reduce cost, because there is going to a cost increase because of looking at all these health factors. So probably all the technologies which drive cost reduction, such as prognostic health management, we can use a lot of data which is coming from the different sensors in terms of digital twin, digital thread, algorithms maybe based on the Kalman filters, machine learning, which can use the data coming from airlines to basically tell us the health state of the system. So these are probably some of the technologies which are going to come up, and largely they are going to be driven by cost model. These are some of the technologies which come to mind. And like besides this, we also have the issue of these kind of zoonotic diseases, which may not be finished with COVID. So there is a very high probability that this kind of transfer mechanism, which is coming animals to humans, is going to go up in future. And so we have to prepare for further such diseases to come. So again, that is something to be kept in mind in all future air travel situations and so on. So again, I don't have all the solutions to these problems. So we will have a panel discussion where we are going to discuss many of these technologies and different aspects of the technologies, which will help us navigate better through this post-COVID situation. So I'd like to stop at this point some of my introductory comments, and I would like to invite Dr. Nitesh Bansal to make his presentation.
Thank you, Professor Ranjan. It's indeed a pleasure talking on this platform today and being invited to share my views on such an important topic. Now, the aerospace industry, of course, has always been the harbinger of new technologies and new kind of thinking and innovation into the world. Largely fueled through a lot of research that happens on the military side of the domain, which later finds its way into commercial use. However, sadly enough, if I may say, the adoption of technologies, digital technologies, the way they have evolved over the last decade or so, hasn't met the same pace. Currently, like you rightly said, Dr. Ranjan, that in the COVID times, it has given an opportunity to rethink how technology would be used in order to not just manage and save costs, so that the entire aerospace industry, right from the MROs to airlines to OEMs and their extended supply chain partners, can become viable again, can start operating again. But we also need to take this as an opportunity to bring in that innovation and that degree of adoption that perhaps the industry has been waiting for. To give you a few examples, of course, IoT has been talked about as a technology, a digital technology, now for almost a decade. But when we look at practical adoption of IoT, how can that be accelerated or taken forward in the current times? The example that comes to my mind is that of a large, aircraft engine OEM and their MRO facility in Asia, where when we had a look at it from the pure connectivity and visibility perspective, we found that by simply providing connectivity across the shop floor and providing real-time visibility, we could potentially, and we finally did, impact their parts inventory. We could look at their machine capacity, the labor productivity and availability, etc., which then resulted in end-to-end turnaround time reduction from 21 days as they used to take before any tail that kind of came in and they could completely turn it around, to net 2 days at the end of that implementation of visibility and connectivity. Their OEE went up from 57% to 70%, and their waste came down by almost 10%. Now, if you count the impact of all of this, this is direct cost saving. And what could be done on an MRO plant could easily be, you can imagine, and carry it forward into the tier 1, tier 2 suppliers and the OEM side. Taking example of a very large tier 1 supplier, by simply putting RFID-based track and trace in place, we were able to improve their throughput by 10 to 15%. The materials inventory went down by 10%. If you think about the extended supply chain, because there are so many tier 1, tier 2, tier 3 partners on whom this entire manufacturing chain depends, implementing simple track and trace using blockchain kind of solutions, which can provide not just supply chain inventory visibility, but also become a mechanism of providing compliance and documentation to carry across the chain without every time every player that gets involved having to repeat that entire process again. And then last but not the least, it is also extremely important that we take note of sustainability. Now, I'm very proud because Infosys last week announced that it has become a carbon neutral company. A 3-decade-long commitment that was made as part of Paris Convention is something that we have achieved, and we have become carbon neutral now. But when you look at the aerospace industry, it has to do something more substantial to get there. It is an extremely important question for the aerospace industry, and perhaps could become a question of survival for the airlines, because it directly not only impacts cost, but also the consumer sentiment. So thinking about how do we bring circularity in design? Today, the way a used aircraft is harvested is not very efficient. And it is only because of the cost that it takes to strip it apart that a lot of those find their way into junkyard and never get recycled. Being able to design the aircraft for recycling, for being circular, would be one big step. Of course, a huge amount of research into alternate fuel technologies, whether it's hydrogen, whether it's electric powered, or any other kind of fuel technology that would turn the entire industry into more green, are the other interventions that we believe are at the verge of taking off, and we as a community can support. So having said all of that, I think still there is a lot that's already happening in the industry. Things like AHM becoming mainstream, and now the regulators having decided to make it as part of their MSG3 certification, etc., I think are very positive steps. So I do look forward to this discussion, because there is a lot that can be done, and COVID may not only just be a crisis, but could be a great opportunity. With that, I'll hand it back to you, Dr. Ranjan.
Thank you very much, Dr. Nitesh. Now I'd request Dr. Samit Prabhu to make his remarks.
Thank you, Professor Ranjan. So the recovery from COVID-19 will be a journey, and we'll go through various phases as we come out of this. In the short to midterm, as Professor Ranjan said, there will be a significant focus on lowering cost. And technology's role in this is to be an accelerator. It'll be about doing things faster. A simple example that all of us have experienced is how quickly we had to adopt technologies such as virtual conferencing to get work done. Earlier, a shift like that would have taken a few years. Now, because of the pandemic, we had to do it in the matter of days. So that's a simple example of how technology can be a disruptive force and really drive significant efficiencies. So in the short to midterm, technologies such as predictive maintenance, digital performance management, automation will play a key role. So if I take the example of predictive maintenance lets you monitor equipment health to avoid future failures during the operation. It uses predictive algorithms along with data from various different equipment sensors to estimate when the equipment will fail. And you can pinpoint the root cause of problems in your complex machinery and identify which parts need to be repaired, which parts need to be replaced. And this way, you can minimize the asset downtime and maximize equipment lifetime. And that's a good example of how you can lower the overall operating cost. Similarly, the level of automation will also increase. For example, using technologies such as vision-based tracking, remote asset control. Again, an example of that would be a system that can analyze video feeds, and then you can augment that video feed with infrared imaging and do detection whether the passengers have fevers or not. And you can automate this entire process of detection and isolation of passengers. Another example is controlling assets remotely. So you can monitor and control equipment remotely by connecting it to cloud-based software, and then the workers can access equipment from their home. So these are some of the short-term to mid-term things that will happen. In the long term, there'll be a strong focus on reimagining the industry and applications themselves. Earlier, we talked about IoT. So when you take concepts like industrial Internet of Things, they will become mainstream, right? So again, we talked about predictive maintenance. So let's build on that, and we'll move from simply being able to predict to being able to do online process control, online asset optimization, which will lead to an order of magnitude improvement in overall system effectiveness. Similarly, we'll move from automation to autonomy. So today, aircraft certainly have automated systems, right? Autopilot is a very simple example of that. Autonomy, on the other hand, has to do with the ability for the aircraft to respond to unexpected hazards, unexpected situations. In this case, the system needs to be able to make decisions on its own without any active intervention from the pilot. So this will then further drive a reimagining of what we mean by transport. So urban air vehicles or flying taxis that involve short point-to-point flights, along with a constrained set of routes that require minimum landing infrastructure, all of those things will become possible. That in turn will drive a reimagining of civil aviation towards transportation as a service, which would include integration with other modes of transportation. So we'll want passengers to move seamlessly from their car or train to an urban air vehicle while keeping that digital thread regarding passenger safety, security intact by integrating across this entire supply chain of transportation. Certainly, this is a very exciting future, and it's something to look forward to. And certainly, we all need to work together to define and evolve these technologies that will have a transformative effect on our lives. Thank you, Professor Ranjan.
Thank you, Dr. Samir, for your comments. So I'd now like to invite Dr. Maheshwar to make his remarks.
Hi, everyone. It is heartening to see that we are all thinking about how do we come out of the COVID, post-COVID, not just survive, but emerge more strongly. And that is, I think, is an opportunity. So I want to ponder on a few thoughts. So in order to review the future, it's important for us to revisit the history a little bit so that we understand how aviation as an industry has emerged from strength to strength. Every time it has faced a crisis like this. No question, this is the worst crisis ever that the aviation industry is facing. But if you look at the past 118 years of aviation legacy, you can say at the start of the aviation industry, the safety was one of the biggest concerns. It was not perceived to be safe. There used to be many accidents, so safety was the biggest concern. And kudos to the aviation industry. It has worked on it. And today, aviation industry is the safest. Aviation is the safest mode of transport, as even compared to walking on the on the street. So that's I would consider as one big disruption and an area which aviation industry has worked. Later, 9/11 created a threat in terms of security, and today we all know that we all feel secure, and aviation industry again worked on it and made it much better, and nobody is worried about security. So now, if I look at the COVID challenge, which is around health, so that's a third dimension to it. So I'm pretty sure aviation industry would work on it. Already I see that in one of the research paper from Harvard, Today, as on today, aviation industry or the mode of travel is still the safest in terms of health. So I think we have to take away some of these perceptions. So in order to survive in the short term, so survivability is the biggest concern and the need for aviation industry. And whether it is in the form of regulations, whether it is sharing best practices around, from airlines, from regulators, I'm pretty sure we would address this soon. The second, the dimension to it is, how do we make money when we face this challenge? I think the technologies like digital would be very, very critical. So the adoption of digital is going to be much more accelerated given the challenge. Whether it is biometric, whether it is touchless travel, or looking at the industry 4.0 by a broader framework of driving efficiency, reducing the cycle time, aviation industry would definitely benefit from faster adoption, and that is going to change the game. Because one of the biggest concern again in aviation industry is not there is a huge risk, and the risk versus reward is still very high. So this would drive away the costs, and many players would get in, and that would again drive the efficiency of the entire system. So I would like to touch upon what we can see as a reimagination of this industry. Not many folks know that already the aviation industry has been working on some of the disruptive technologies, which are very fascinating. And for 10, 15 years from now, I'm pretty sure the way we look at aircraft or the propulsion systems, the entire mode of transport is going to look very different. And it is not just because of the COVID, but the journey of reimagination has already started several years ago. So the biggest driver for the market and the industry is around sustainability. So I would like to talk about 5 disruptive technologies, or the technologies which are going to propel the future. So, and they are, I would say, in the time frame of around 10 to 15 years. So one is around supersonic aircraft. Very soon we would see supersonic aircraft in the business travel. Again, 30% fuel efficiency as compared to Concorde, and already a number of companies are already working on. It might delay because of COVID, but we would see that as one of the trends. The second thing is around the aircraft systems. There are many different versions of reimagining the aircraft. For example, blended wings, or flying V, or double V, and using shape memory alloys, for example, and reimagining the way we would think of wings. So I would imagine a lot of developments and technologies around aircraft structures, the way aircraft looks, the aerodynamics, and all that. The third is around propulsion. Propulsion is going to change the game, and we are going to look at very disruptive technologies like open rotor, very large diameter, fans, high bypass ratio engines, which would reduce the fuel burn by almost like 30%. And the conventional propulsion systems would not be sufficient to either reduce the emissions or reduce the fuel. So high bypass ratio engines, and in the short term, and then in the long term, electric, hybrid electric, and fully electric aircraft. Again, by 2035, it's predicted that the airlines would offer commercial operations with hybrid electric aircraft. So around say 50 passenger seat aircraft would be the candidates for such mode of transport. And we are going to see more and more electrification. So the way you look at aircraft, which is going to be powered by battery and a small jet engine, is going to change the way we look at the aircraft and the propulsion systems. Then on the fourth one, I would like to talk about the technologies like digital. We talked about large scale adoption in the entire ecosystem with the Industry 4.0, again, advanced versions of Industry 4.0. And it is going to again, make the air travel much more automatic, and the ecosystem will thrive on digital technologies. Finally, I want to talk about the manufacturing technologies like additive. It's going to change the way we would reimagine the components and the way we would manufacture. You don't need large factories when it comes to additive. It would be a smaller factory and fewer people. Again, in terms of weight reduction, cost reduction, it would be matured by then, and we would be able to reimagine, the designs. So there are many things to come. And finally, I think that once the aviation industry comes out of this COVID, in say 3 to 5 years from now, we would see acceleration of all these technologies. And it's an exciting opportunity for technologists and engineers and industry folks to really look at these trends. And we need to work together to emerge as winners, not as the industry which was hardly hit by this disruption.
So thank you very much for the extensive comments on this whole technology theme, Dr. Maheshwar. And now I'd like to invite Dr. Shiv Kumar to make his comments.
Thank you, Dr. Ganguly. It's a real pleasure to be among such a distinguished company today. And one of the risks of being the last speaker is that many of your topics are usually covered by others. But let me try to be a little more specific on some of those things. But I think the kind points that were made by my colleagues here are really excellent. As the old saying goes, that it's a terrible thing to waste a crisis. And if at all we have learned something today, is that the COVID crisis that we are facing has really spurred us to think, catalyzed us, galvanized us into thinking things very differently. And I would like to actually talk about 4 topics, and I'm trying to keep myself as close to the theme as what has been catalyzed by COVID. And I'm trying to keep it a little restricted towards that. So the 4 points that I would like to talk about is the new confluence that we are going to see between medical sciences and aviation engineering. The second one I would like to talk about is the reinvention of aircraft interiors and privacy, how we are going to see this in the years to come. The third point I would like to talk about is that the world has seen clean air. After a very long time, the world actually has seen clean air, and they're going to want more. So what is going to be the ramifications of that on the technology trajectory that propulsion is going to take? And lastly is always the first person to take the brunt of any disruption is the MRO. So we have to develop resilient, disruption resilient MROs. So around these 4 topics I would like to talk about. So medical science has always contributed to aviation engineering in terms of human comfort, the human physiological aspects. We all know that a cabin altitude of 8,000 feet and a cabin altitude of 5,000 feet are distinctly different in terms of passenger fatigue, in terms of passenger comfort. The passenger arrives much more cheerful, much more fit on the other side of especially long journeys. And there have been the aspects like these have always been brought into aviation engineering. But the first time we are really being spurred to think about medical aspects. How are we going to ensure the medical well-being of passengers in an aircraft? Because this is not going to be the last pandemic. And if at all we have learned something, there are going to be many more pandemics to follow. And what will be the nature of that beast? Nobody can tell whether it's going to be through droplets in the human saliva, whether it's going to be touch. We really don't know. So we would have to reimagine systems like environmental control systems on aircraft. Cabin pressurization has to be relooked at. Do we have to have flow models that look at scavenging air from passengers in the most optimum manner? Are we able to give a very high level of fresh air that is being introduced in the cabin? These are going to be things that are going to be on the minds of aviation engineers in the future, because that is the way they have to design the next generation of aeroplanes. Antimicrobial coatings are so material sciences have always been very closely working hand in hand with aviation engineers. But do we have to look at new aeromedical aspects wherein you have to choose an interior material which is not only lightweight and doesn't burn, but is also naturally repelling the bacteria and viruses? So this is going to be something that we are going to be looking at. And we are going to have a completely new paradigm shift in the way we look at these systems test these systems, and how do we certify these systems? These are going to be occupying our thoughts for quite a long time in the years to come. Now, aircraft interiors, the reinvention of cleanliness and privacy, I would say. No longer a passenger is going to be willing to share an aircraft which is not really clean. They would want it to be squeaky clean every time they travel. They are not going to tolerate a passenger sitting next to them who's been holding a handkerchief to their nose and sniffing into that. That is something that's going to become unacceptable. So, are we going to use technologies like a health passport, for example, for a passenger? Are we in a position to actually, like biometrics, are we able to come up with a health passport? Is the seating inside an aircraft going to be optimized based on what is the risk level of each passenger versus the other? So these are going to be thoughts that are going to occupy our minds for years to come. We are going to look at perhaps new designs on how do we sanitize an aircraft? Do we have quick release assemblies? Can we change the interiors of aeroplanes? Can we do thorough cleaning inside an aircraft? And are we a few years ago, if somebody had said that you have to remove seats inside an aircraft, they would have said, it's impossible. But if anything, COVID has taught us, it has taught us to reimagine things. And what we thought is impossible in the past has now become the new imperative. This has become the new way of life. So this is something that I feel that the aviation community would be really looking at. And the two aspects of passenger privacy is directly in opposition with passenger packing density on an aircraft. And these two things have to be optimized in a very, very new ways. And the other aspect that we would really require to look at is, can we make the passenger experience less touch, more gesture, more voice? We have always looked at cabin, the crew of the aircraft, the pilots. We have been looking at human engineering aspects for them. Human machine interface has been always pilot centric or crew centric, but now it has become passenger centric. For example, can you open a lavatory door with a gesture or a voice command? These are things that will have to come in a new way. And your amenity kits on an aircraft will be having certain health related things on board. So these are certain things that we are definitely going to see change in the years to come. Coming to the aspect of cleaner air, the world has seen clean air. We have seen drastic reductions in nitrous dioxide, carbon dioxide. We have seen particulate matter dropping drastically. The combustion particulate matter, which is less than 2.5 micron, is a devil. To get rid of that is almost an impossibility. So now the world, when they know that you can actually reduce the effect of pollution on the atmosphere, they would want more. So it is going to spur new methods of propulsion. And I think Dr. Uma had mentioned about electric propulsion. Yes, it is indeed true. We are going to see synergies between internal combustion engines and electric on the same shaft. You would have a combination of both of them running or either one of them running, and we'll be able to optimize the power plant on depending upon the regime of flight that we are operating on. So these are going to be absolutely new imperatives. Who knows, we might see superconductivity fueled through cryogenics, so that we will have compact electric motor systems and generation systems on board. And lastly, coming to the MRO part of it, I would definitely say there are three things that would really require to leverage. That is the digital connectivity. We require to connect, we require to collect, and we require to act. So we are going to see larger connection of systems where we can milk in the data, use this huge data to be able to run prognostics and act rather than react. So that is the way we are going to change the way to reduce the footprint of MROs. And the digital twin is going to be a game changer. It is no longer a luxury. It is an absolute necessity to survive in the new world order, and where we want to reduce the maintenance overloads. So there are a few of my thoughts. Thank you very much for that.
Thank you very much, Dr. Shiv Kumar, for your broad perspective on the problem. Now we have some time for some discussion on some of the topics which were raised. So I think we have covered a huge quantity of topics, and I'm just going to make some summary remarks and then maybe ask each of the panelists to just say some things regarding some of the points. So I think from what we have seen till now, that there are a whole host of technologies which are likely to become important in this post-COVID situation. And so one of the questions which comes is, given that cost is a major criteria and all these health-related issues are bringing up higher costs, where do we use technologies to actually balance the cost also? Because as far as say, airlines are concerned, there is little scope for them to increase passenger tickets and so on, ticket prices and so on. So that's one of the things is how do we manage cost versus performance trade-off with all these new technologies? So that's one question to think about. Second would be possible technology gaps which we currently have. Like there are very promising technologies such as say blockchain and even digital twin and so on. But the question is the people currently or engineers currently may not be well trained in that. So maybe some of the key technology gaps which we need to fill in our various institutions. And the third question could be possibility of when we are making all the things digital, then possibly you have a situation of sensor failures, you have a like possibility of some kind of cyber hits on your system and so on. So those are some of the problems. How do we counter the fact that if we have open web-based systems everywhere, then how we are not susceptible to hacking and such problems? So with these remarks, I will again like to call the panelists in the same order to make some general comments on some of these topics. So I'd first like Dr. Nitesh to say a few words. Thank you.
Thank you, Professor Ranjan, and I think it's a great perspective to have as to whenever we talk about implementing new technology, given how competitive the industry is and how thin the margins of operation are, that cost always becomes a major driver. But digital technologies lend themselves to scale. So adopting digital technologies is also the answer for when it comes to the trade-off between cost and implementation. Perhaps what we need as the industry, and something that we are doing here on the SAE India platform, is the need for higher collaboration so that we don't keep on reinventing the wheel. The cost of implementing once, if that could be distributed through an OpEx model across the players in the industry, then adoption and running costs will automatically lend themselves to profitable operations. So if there is and I'm just taking one example, if there is a blockchain solution that the industry would like to adopt, which will allow them to have a better value chain of documentation, technical publication, certification, and if that is something that could be commonly adopted and the industry would come together to subscribe to it, the cost of operation becomes meaningless. It's basically not going to be material in that sense. Similarly, when it comes to a lot of great topics that Shiv and Uma talked about around whether it's propulsion systems, whether it is a combination of health and medical sciences onto aerospace, again, a lot of these need to be taken up as a collaborative innovation ecosystem, so that the costs, etc., can be initial costs could be shared, and then because the technology lends itself for scale, it can be easily adopted. So that would be my 2 cents on it. Perhaps just reflecting on the point on tech gaps, I think today the biggest technology gap that we see is perhaps and this I'm talking from the MRO and shop floor perspective, is just lack of connectivity. And in the past, perhaps technology options have been not so easy to adopt, whether you put Wi-Fi or some other kind of connectivity in there. But now with coming of 5G and the ability for companies to actually spin off their own private 5G into the shop floor, and a lot of these plants are extremely big plants, that can provide both the required mobility and the throughput with the high bandwidth as is needed for the kind of connectivity that is required. So there are technology disruptions which are coming into play, which can enable that. But that's my 2 cents, and I'm sure others have other things to add. Thank you.
Thank you very much, Dr. Nitesh. I'd like now request Dr. Samir to make his comments.
Thank you, Professor Ranjan. So I'll try to address the three issues that you brought up. The first one that you mentioned was cost. And that's where one example of how you can drive cost down is, I mentioned predictive maintenance earlier, which is instead of doing scheduled maintenance, which is time-based, and you perform the maintenance whether the system needs it or not, what predictive maintenance does is you do it only when it's required. So that is one kind of simple example of how you can reduce the cost, right? Increasing the uptime of machines is another way in which you can drive down the cost. So these technologies, as was discussed earlier, right? You'll move from simply being able to predict to take over active control, and through that, optimize the overall system performance. So those are some of the developments that would happen. The other aspect you mentioned about when you have systems like this, sensor data becomes critical, and what happens when there is a failure in the sensors, right? So how can the system deal with that? So a couple of different ways. One way to do that would be, instead of relying on a physical sensor alone, you can create virtual sensors. So for example, you can use algorithms that, let's say, fuse data from multiple sensors and create a mathematical model that would basically reflect a physical sensor, right? And again, back to that point about cost, if you want to drive down system cost, you can eliminate a physical sensor and replace it by a virtual sensor, right? And that is where technologies such as sensor fusion and others can play a big role in making sure that even when, let's say, the physical sensor fails, there is a virtual sensor that can keep the system performing, maybe in a kind of a limited operating mode so that it doesn't cause damage, and then you can schedule it for maintenance. Right? And the third aspect that you brought up was about training and making sure that the engineers are trained to be able to operate in a world like this. There's, again, a couple of different ways in which you can go about that, right? One is it would require a very strong collaboration between industry and academia so that students who are studying today, when they come out, when they graduate, they're equipped to hit the ground running. That can be done by, if you look at students today, they are working on, quadcopters and things like that. So, autonomous systems is something that students are getting exposed to very early. They're building these systems, they're deploying those systems, and that helps when they join the industry. Also, the training of the engineers would also shift, right? Today, you might go, earlier you would go to a training class, you get trained for 2 or 3 days, and then you come back to your work and apply that training. And because of all these technologies like cloud and others, training will shift to, you get training at the point when you need it. The system can be smart enough to recognize, oh, looks like you're doing this. Here's a small training module that will help you get over that hurdle and make you effective and efficient at that point in time. So those are some of the ways in which technology can really serve to accelerate how the pace at which we make this transition. Thank you, Professor Ranjan.
Thank you very much, Dr. Samir, for your comments. I would now request Dr. Maheshwar to say his viewpoint.
Yeah, I think these are interesting topics, and I would like to share a few thoughts around some of the trends that we see and how those trends, the technology trends, are going to address some of these challenges. First, cost. Cost has been always a challenge for aviation industry, whether it is airlines, whether it is OEMs, whether it is the MRO shops. And when I look at the disruption because of COVID, as I discussed, the digital adoption is going to definitely make a change in the way we look at the different operations, whether it is MRO or manufacturing or even the design activities. So we are going to see digital technologies improving not only efficiency but driving away the cost. Take example of let's say design. It used to take around 10 years to design an aircraft or a propulsion system, but over a period of time, with more and more automation and advanced simulations, knowledge-based systems, we are going to reduce that cycle time. For example, so digital adoption, again, usage of augmented reality or virtual reality in shop floor so that we minimize errors and drive the efficiency, or blockchain, in tracking of the entire the component history and making sure we have the right procedures. So things are digital twins. Digital twin not only to predict maintenance, but you can use digital twins to simulate manufacturing operations or to simulate supply chain. There is no limit to it. So when we look at the digital technologies, we can apply in various aspects. And one of the things which I believe the industry would need is really collaboration among all the players, so that we complement the technologies. So there would be procedures. There's a need for guidelines. For example, how do we develop a robust digital twin? For example, there's no procedure. Today it's a proprietary information of each company. Maybe there would be standards, and that would make even smaller companies to use. And I think that would really drive the cost across the board. We need to drive the cost not at big OEMs, but across the entire ecosystem. So that's about the cost. The second thing is around, you talked about the sensors. Again, I would say the algorithms, the simulations would become very handy. Even for example, additive manufacturing would change the way we would think about sensors. You can have some of the smart structures, smart materials, which would have sensors in it. And and we can design foolproof systems, and there would be a lot more intelligent algorithms to detect any anomaly or any failure of the sensor. For example, even today, with very few sensors, we get around 1 terabyte of data. When an aircraft flies and lands, it produces 1 terabyte of data. And we hardly use all the data, because these algorithms are still developing, and there's a lot more intelligence we can build in, even with the current data. But imagine if we develop algorithms to simulate large data, and again, with collaboration from different airlines, different OEMs, if they all come together and share the data, it's going to make the aviation industry much better. So today, again, it is used in different pockets, and there are algorithms which are proprietary to each company. But if the industry can collaborate, we can actually drive a lot more intelligence and a lot more efficiency. And the third thing is around the training and the knowledge base. So I see that again, the digital technologies will come in play. The aviation industry is very much risk averse. It has to be, but there is a lot of knowledge and skill which is in the form of manual, form, and it is residing with fewer people and fewer companies. I would say at some point of time there would be a democratization of some of this knowledge as the new technologies would come in. Some of these technologies have to be spread out, and digital technologies would come in handy. For example, today we see concurrent engineering, right? Take example of GE. We have 7 global centers, and each team virtually designs in a concurrent way. The product design and development is virtual, so we already collaborate. But can we take it to the next level? Of course, yes. VR, virtual reality, augmented reality, mixed reality, all these technologies would be so much handy in upgrading the skills. And finally, I would say that there is again a big disruption coming in the form of startups. The startup mentality in aviation is going to change the game. We talked about all those disruptive technologies, which is electric or additive or digital. Most of these inventions and most of the adoption and challenging the industry is through the startups. So aviation industry has to think like a startup, not like a long cycle legacy based industry. And I'm sure it would adopt. I already see, for example, the hybrid electric or electric aircraft. The pioneers and the inventions of these technologies are actually from most of the startups. That is again a democratization of aviation industry, or democratization of flight in some aspect. So I think there are a lot of challenging and exciting aspects as we look at some of these themes. Thank you.
Thank you very much, Dr. Maheshwar, for your comments. Now I'd like to request Dr. Shiv Kumar to make a few points about these topics.
Yeah, I must say that a lot has been said about digital technology by my co-panelists, and I quite agree with all of them. In fact, I really like what was said by Nitesh, that scale is the answer actually. So cost can be only combated by scale, and if there is widespread adoption, then definitely the cost can be controlled. I won't really want to say much more on that particular part, but definitely I see that aviation industry has got a very high requirement of skilled manpower for maintenance of aeroplanes. And what we require to see in terms of the impact of digital transformation is the digital connected worker, where cognition, recognition of the problem, the diagnostics, everything is served to him in a matter of milliseconds. And that is the kind of transformation that is required to make sure that the skill level, the upskilling that is required for the digital worker is very minimal. And that itself will bring about a lot of resilience to disruption, because finding workforces can be quite a challenge. So I would definitely say that the requirement of skill and the sheer number of people that are required for aircraft maintenance can be addressed in a very significant way by digital transformation. One thing which is very close to my heart is the blockchain part, and being a former maintenance engineer, the paper trail that a component leaves is a very massive trail, and it is very difficult to establish the antecedent of components, especially when they've gone through overhauls. And I would definitely say a blockchain based component certificate is the need of the hour, and if we can implement that, I would say it's a huge enabler to validate the authenticity and the veracity of a component that is being used. So that is definitely, I would say, a very major part of the digital contribution. Now, when it comes to multi-sensor fusion, this is something very close to my heart. And while you rightly pointed out that systems could lose sensors and we could lose an entire system, the graceful degradation has to be built in as a feature within the design. But what is more important is we have to move away from the traditional high-cost sensors and move towards low-cost sensors, yet not compromise on the quality of our solution. So that is something that I will see, that I see as a very big change that is going to be there in front of us in the years to come. And if I may be bold enough to say that I think the urban air mobility and the unmanned aerial vehicles are going to show us the way. The point which Dr. Uma made on the democratization is again something where he really touched a chord. That is something that we will see from small players coming together in multi-sensor fusion and giving you high order solutions at very low cost. Thank you very much.
Thank you, Dr. Shiv Kumar, for your comments. So I think we had a very productive discussion, and we discussed various technologies which have now come out. So just to summarize, a few of the technologies are blockchain, digital twin, and all of these in the context of maintenance, which is a very important problem, because the MRO sector is probably going to boom a lot in the coming future in the country. So that's one of the things to take from this discussion. So I think I would like to thank all the panelists for taking part in this discussion and giving their valuable time for it. And there are various points and subtopics which have come out from this discussion, which would be useful to all the viewers of this session. So actually, if you go through the talks carefully, you will find various points and themes discussed, which can be of interest to, if people are pursuing some problems or they are startups kind of looking for problems to solve. And so again, that would be a very useful outcome from this particular presentation. So I think even though COVID is with us now, and hopefully it will go off by next year, some of the impact which it leaves may be permanent in the sense of switching to like digital mode for various things, people getting comfortable with this digital technology, and also it bringing down the costs in various places. So some of the cost reduction may not be good for airlines, but they may find some way to cope up with it by using the digital technology in some different manner. So that's some of the outcomes of this particular technology. So once again, I'd like to thank all the panelists and bring this session to a close. Thank you.
Thank you all the panel members, Mr. Nitesh, Dr. Samir Prabhu, Mr. Uma, Mr. Shivkumar, for sharing your thoughts and insights on the technology landscape post-COVID era. Thank you, Dr. Ranjan, for moderating the session. Yes. Hi. We have a few questions here in the Q&A window, but as we are already running late and in the interest of time, let's just take one question. Dr. Ranjan, we have one question here. How organizations have to manage between technologies that will help short-term versus long-term in the COVID era, especially with uncertainties around?
Okay, yeah, that's a good question. I'd like to start again in the same sequence. I'd like Mr. Nitesh to take this question.
Thank you, Dr. Ranjan. I think managing technology in short term versus long term is essentially a question of ROI. And from what I've seen our customers do and what the industry is doing is to look at those technologies that will immediately enable some working capital and operational cost reduction. And those could be from a production side, this could be manufacturing operations and planning side of things. And from a post-market or aftermarket services side, it could be a better planning options on doing how the MRO operations is maintained and managed, etc. But clearly, being in an industry where the life cycles are longer, each of these will have to be taken from a long-term view as well. But I think those are some of the things that come to my mind.
Yeah, I'd now like request Dr. Samir to take this question.
Yes, so certainly I think in the short term, right, it's about reducing cost. So I think that's where the technology focus will be on things like predictive maintenance, right, digital performance management, automation as much as possible so you can drive down the cost. And that's where the focus will be in the short term. And the long term is where you can look at technologies that completely change the way the business model works or the way the entire system works, right? And that I think that's where the short term allows you to get through the capital shortfalls you may have, and the long term allows you to completely reimagine and change the way business gets done and puts you in a very strong competitive position. So, thank you.
Thank you very much. Mr. Maheshwar?
Yeah. So I think in the short term, of course, we have a challenge to survive. So I would say if we deployed digital technologies, we would drive a lot of cost out, drive efficiency, and the money that we would save, that would pay off for long-term investments. So now, again, one big disruption that we talked about is startups. We don't have to develop all the technologies in-house. I think it's a time to deploy the ecosystem, the startups, the universities, other small-scale industries, so that as an industry, we can develop technology, not to wait for a long time. So short-term focus, yes, but we should not lose the long-term sight.
Mr. Shivkumar?
Yeah, very quickly, I'll pitch in. I quite agree with what Nitesh and Samir and Ma have said. Actually, the appetite today for airlines operation is very low with respect to new technologies. Unless it has got a direct impact on the bottom line in terms of optimizing operations cost, it's not going to be adopted so easily. So as an industry servicing aviation, we have to be having extremely good, powerful, persuasive stories to tell customers, be it airlines or OEMs, that what is the direct benefit, immediate benefit of the technologies.
So definitely, there's a plethora of technologies out there, digital and others, traditional. But we should be able to showcase the value proposition very emphatically. Otherwise, it will not get adopted, because in a cash-starved industry today, that is an imperative. But the long-term vision also cannot be compromised, because this is a long cycle business, aviation, and that's where I feel collaborations are going to be there. And as Uma rightly said, that I think there'll be disruption in the form of startups coming in with their new ideas. Thank you.
Thank you very much. Satish, back to you.
Thank you. Thank you, the entire panel, for the wonderful session and sharing your perspectives. With that, I formally close this panel discussion and passing it on to Dr. Ravi to share closing thoughts for day one of this conference.
Yeah. Good evening, good morning, and good afternoon for all the people who have joined this particular day one proceedings. Thanks a lot for your time. It was a wonderful session today. And so I'll just summarize the day one proceedings. Just give me a minute. I'm just sharing my screen. So we started with the inaugural session, and we had a wonderful talk from our president, Dr. Bala, and then we had a good overview from Damu. Then we had a wonderful messages from SAE International president as well as the CEO. Post that, we had the guest of honor keynote speech from Dr. Preet Banerjee. Then we had a wonderful talk from Dr. Sumantran, and they have touched upon the various challenges that the post-COVID era that aerospace industry is facing, what we need to do and things like that. Then we started the technical sessions. Okay, so in the first business theme, we had the reimagining aerospace industry in post-COVID era. We had a wonderful keynote address from Pradeep. It was it was a wonderful insight how the entire aerospace industry or ecosystem is coming together to solve the problems that are faced with the pandemic. Then we had a beautiful panel discussion, which was led by Dr. Kota. It was very informative and inspirational for all the aerospace professionals. Then we had the first technology theme discussion, more specifically on the technology landscape in post-COVID era. We had the keynote address from Savia, and he has touched upon the entire technology landscape prior to the COVID and post-COVID, the short-term and long-term. It was a lot of insights. And then we just had this wonderful panel discussion. It was chaired by Professor Ranjan Ganguly. And it was a very, very enriching discussion. And definitely it is a lot of insights that have come from the day one. Of course, there are certain technical glitches. I'm sorry for that. We have noted down all your questions. We have seen good amount of traction on the chat box. We have collected all those questions. We'll post those answers in our website, and also feel free to send us any questions post this session as well. That concludes more or less the day one. I just want to briefly touch upon the day two proceedings. We will start the session at 4:30 p.m. India time tomorrow. So we have close to around 40 minutes time for the sponsors, the virtual booths. This is a parallel session. Then we have a wonderful keynote speech from Dr. Richard Greaves. He talks about the aviation industry, the evolution of the aviation industry. It will be very inspiring. He is one of the key persons in the aerospace industry. Then we have the keynote speech from the principal sponsor, Mr. Enrico. Then we will have the second business theme, more specifically focusing on the challenges and opportunities for safe and sustainable operations. We will be touching more from the airlines, MROs, regulators in this particular session, and it will be a very, very informative session. This session, we are going to have the first keynote address from the Airbus, then the panel discussion. It will be anchored by one of the senior ICAO person, Mr. Pradeep Pathak. Post that, we will have technology theme 2, which is about disruptive technologies in aerospace and aviation. So today you heard about some of the technologies that are disrupting aerospace. More specifically, we will discuss more there in tomorrow's session. So we will have a keynote address from Mr. Ambar Dubey, who is leading some of these drone and drone-related activities from Ministry of Civil Aviation. Then we will have the wonderful panel discussion that will be moderated by Professor Ravi Rajamani. Okay. Post that, we will have the valedictory session. We will summing up, and we will also lay out the plan for the next sessions that are going to come. So that's a quick summary about day 2. We would like to join us tomorrow at 4:30 sharp, and have a wonderful night for all the people who are joining from India, and wonderful day for the people who are joining from US and the rest of the world. Thank you. Thanks a lot for your time. It is really inspiring to see so many people coming together and talking about the challenges that we are facing today. Thank you. Thanks once again.